So guys, as I told you in yesterday's class, we finished inelastic collisions in yesterday's class. Today's class, I'll be doing the elastic collision derivation. Now, you will feel lost when you guys are doing this specific elastic collision, this specific what do you call derivation. Reason is because this has no ending only. It's like you keep solving, you keep changing the terms, and you keep getting the answer. Obviously, you won't understand what I meant. But the problem here is in the previous derivation, elastic collision, we had a end point. This specific concept has no end point only. It keeps going on. But just because it has no end point doesn't mean it's not important. It is very, very, very important. Again, as I told you the other day. Now, what's the main difference between the derivation as well as this derivation? If you recall the previous derivation, we had two diagrams, and here we have three diagrams. Fine. So obviously, what I'm going to do, I'll write the concept here. This is before diagram. This is during the collision, very important, and this is after the collision. So this is very important. I'm going to take the same square blocks. I'm going to name them M1. I'm going to name this as M2. Done. If you remember the previous case, I told you one of them was not moving. Same thing here also. Second one is not moving. So U2 is equal to 0, which means what is actually moving? U1 is moving towards whom? Towards M1. That's how it is. That's how it works. Now, during collision, what happens? They come in contact. So contact has to be shown. Then later what happens? Guys, think for a second. The same car example, don't you think the direction of it will change? One is the hit. Or best example is just take two gym balls. Okay. When two gym balls hit each other, they tend to move in opposite directions after the collision. So what happens here is after the collision, their direction changes. That's important. So even after draw M1, M2, but this time you will not write U1, U2, you write V1, V2. Why? It's after, no. Therefore, it has to become V1 as well as V2. So you write V1 and V2, but both of them are going in this direction. One of the direction you guys should choose is just that in this question, in this derivation, I'm choosing the direction towards my right side. Okay. That being told, you can choose towards the left also, but right makes more sense according to me here. Again, if you remember, how did we start the previous derivation? We wrote something called as conservation of momentum. Same thing we do here also. So write that in as conservation of momentum. Momentum, you write, underline it. Same concept we will start. Is just that, okay, fine. M1 U1 plus M2 U2. The explanation of this is in the previous video itself. Same concept will be equal to M1 V1 plus M2 V2. Absolutely zero changes here. Now here, same concept. U2 was equal to 0. Correct? How do we know it? Look at this. Look at the marking here. U2 is equal to 0. Automatically, the whole of second term becomes equal to 0. So M1 U1 is equal to M1 V1 plus M2 V2. That's all. M1 V1 is equal to M2 V2. I will box this. I will mark this to be equation 1. Absolutely zero changes. Again, just like the previous derivation, what did we do? Once we finished conservation of momentum, we started speaking more about kinetic energy. To be more precise, we spoke about loss of kinetic energy in the previous case. Here, instead of talking about the word loss, we'll talk about conservation of kinetic energy here also. Fine. So again, how many bodies should I talk about? Two bodies. I'll talk about both of them. Again, formula is very simple, half mv square, but it will become half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Whatever happens, don't get your first step wrong. What am I trying to do? I'm talking about U1, U2, V1, V2, both at the same time. That's exactly how it works. Now, the good thing here is we know about U2. This becomes 0, which means on the left-hand side, only one term remains, which is nothing but half M1 U1 square. On the right-hand side, both the terms remain. Half M1 V1 square plus half M2 V2 square. Now, in the previous step, what we used to do here is we used to always assume V1 is equal to V2. We are not doing that here. If you're able to recall here, but I'll go one more step here. On the left hand side, I'll keep half as it is, m1 u1 square also as it is. The right hand side, there are two parts, and in both the parts, I can see something common. Obviously, it's not the letters this time; it's the number. So to make life much more simpler, I'm going to take the half common. It becomes m1 v1 square plus m2 v2 square. Getting it? Obviously, half and half gets cancelled. After cancelling whatever is there, keep it as it is. But now, Think for a second. From equation 1, I know something. Guys, this is the place where things, okay, before that, 1 second. I'll mark this to be equation 2 for a second, after the cancelling of the halves. This is, so if you see, in one page, I've got 2 equations. Right now, it's all about using whatever we have to get whatever we don't have. I'll repeat that. From at this point of time onwards, it's whatever we have. We're going to use that and try to get whatever we don't have. Okay. Now, from equation 1, which says this one, M1, U1, that one I'll copy right now, because I can't keep scrolling every time. M1, U1 is equal to M1 V1 plus M2 V2. This I have. This is equation 1. Now equation 2, after getting cancelled, I'll write here from equation 2. There's a reason why I'm doing this. You might feel I'm trying to repeat things. Nothing. I'm writing it in order to make the next step simplified. M1 U1 square is equal to M1 V1 square plus M2 V2 square. Okay. Equation 1, equation 2, I repeated. Now focus. See what can be done. Okay. See what can be done in equation 1. Okay. Guys, you know what? I forgot to write one step. Just a small step. No worries. Listen up. What I'm going to do here is I'm going to bring all the M1s to one side. If you I forgot to see that. If you see there are 2 parts with M1 here, I'll bring all the M1s to one side. So after shifting it, it becomes M1 U1 minus M1 V1 is equal to M2 V2. All the M1s are on one side. Since they are one side, I'll take common. So it becomes M1 into what remains? U1 minus V1 remains is equal to M2 V2. Whatever answer I got right now after shifting all the M1s to one side, I'll mark that to be my equation number 3. So it's like equation 1 was also used to get equation number 3. Similarly, equation number 2 should give me equation number 4. I'll try that. From equation number 2, which said M1 U1 square is equal to M1 V1 square plus M2 V2 square. Okay, I just copied from this part basically after cancelling the halves. Fine. What I was supposed to do? For me to find equation number 4, bring all the M1s again to one side. So it becomes M1 U1 square remains as it is. This part gets shifted to the left-hand side, becomes minus of M1 V1 square is equal to M2 V2 square. Now on the left-hand side, whatever is common, take it outside. M1 is common, then U1 square minus V1 square was remaining is equal to M2 V2 square. So equation number 1 helped me get equation number 3. Equation number 2 helped me get equation number 4. Done. How do you remember? Odd numbers. 1 gives 3, 2 gives 4. Okay. Now you have equation number 4 and equation number 3 right now. Using this, let's try to get equation number 5. How do we do it? Again, very simple. Dividing. I mean, now do you realize as to when I told why this is an unending process, keeps on happening. Okay. So we divide equation number 4 with equation number 3. Copy it properly. Equation number 4 says M1 U1 square minus V1 square. Now, if you ask me, sir, how do you remember so much 4 and 3? Because see, in 4 and 3, we shifted everything to one side. I can see M1 on the left-hand side, and both of them are meant to be cancelled. That's what I'm trying to do. And I write the more complicated looking equation, which is equation number 4 on the numerator part, divided by the lesser complicated equation in the denominator. So it becomes M1 into U1 minus V1 is equal to, right hand side becomes M2 V2 square divided by M2 V2. That's it. M2 V2. Now think and answer. This is more like math. M1 gets cancelled. We always feel that U1 and V1 can't be cancelled. It can be. How? Look at the numerator. Before that, M2 gets cancelled. V2 and the square gets cancelled. Okay, only V2 is remaining on the right-hand side. Fine. On the left-hand side, if you see the numerator, I can write it in terms of A plus B into A minus B. U1 plus V1 into U1 minus V1, whole thing divided by U1 minus V1. Okay, I will cancel both of them. This is just to prove that it can be cancelled. So I got an answer for V2. U1 plus V1 is equal to V2. I hope you guys remember. This is equation number 5. So till now we've got 5 equations. We are not yet done. Okay. We keep going. It is not difficult. It's just that we'll have to keep going. Now understand. The pattern goes like this. Odd number, even number. Fine. Once you get equation number 5, you will take this, substitute it back in equation number 1. So substitute equation number 5 in 1. Getting it? Now, I'll copy paste the one first equation here. Keep scrolling. One equation number 1 is here. Yeah. M1 U1 is equal to that equation. I'll copy paste it. M1 U1 is equal to M1 V1 plus M2 V2. This is the equation number 1. But I'm telling we will substitute 5 in equation 1, which means wherever there is V2, which is here, I will replace that with U1 plus V1. Okay. So left hand side remains as M1 U1 as it is. Right hand side M1 V1 remains as it is, plus M2 I'll use bracket and outside bracket, and inside the bracket I'll write it as U1 plus V1. Obviously do math here. So it becomes M1 U1 is equal to M1 V1. Multiply the M2 throughout, becomes M2 into U1 plus M2 into V1. Getting it? This is what I've got. Again, what and all to do right now? Listen up. In the previous time I told you, bring all the M1s to one side. After equation number 5, the thing changes. Bring all the U1s to one side. So this part comes to the left-hand side and we'll merge both of these together because both of them are V1. Okay. So I'll bring all the U1s to one side. So M1 U1 minus M2 U1 is equal to whatever is left. M1 V1 plus M2 V1. On the left-hand side, you can take U1 common. That's the whole point as to why I bought it. M1 minus M2 is equal to V1 you take common, M1 plus M2. This is what we have the answer as. Now, what am I supposed to find? Keep the V1 there itself. Now, if you ask me why, we found V2, no. I'm supposed to find V1 also right now, no. Can't be partial. So find V1. So keep the V1 there itself. U1 into this bracket remains as it is. The right-hand side brackets goes to the denominator, becomes M1 plus M2. So V2 was found as equation number 5. V1 I found as equation number 6. Okay. Now don't get scared. There's only math going on. Okay. Now, once you get, this is the last step, almost the last step. Fine. Once you get V1 also, you've got equation number 6. This is the only part you're supposed to remember. Till then, one pattern was being followed. No. Equation 1 gives equation 3. Equation 2 gives equation 4. Equation 4 and 3 gives equation 5. Once equation 5 comes, odd number, equation 5, substitute that in equation number 1. But the last, since we're ending with this, remember one thing. Substitute 6 in 5. That's all. Okay, this is the only thing you're supposed to remember. There's no pattern here. Now, that's it. 5 is what? 5 is U1 plus V1 is equal to V2. I'll copy that. U1 plus V1 is equal to V2 is equation number 5. I am telling substitute 6 in 5. Fine. So U1 remains as it is. Instead of writing V1, since we know the answer, write U1 into M1 minus M2, whole thing divided by M1 plus M2 is equal to V1. That's all. Okay. That's all. Now, what can maximum be done? Maximum, we can take LCM. Fine. Anything else apart from that? Nothing else apart from that. So I'll take LCM. So LCM will be obviously M1 plus M2 itself. LCM here. I'll crisscross. So it becomes U1 into open bracket M1 plus M2 plus U1 into M1 minus M2 is equal to V1. I'll go one step further. I'll open the bracket. So it becomes U1 M1 plus U1 M2 plus U1 M1 minus U1 M2 whole thing divided by M1 plus M2 on the right hand side is equal to V1. Now see what can get cancelled. U1 M2 got cancelled. Now U1 M1 plus U1 M1 gives us 2U1 M1. 2U1 M1 divided by M1 plus M2 gives you V. Guys, I think I've gone wrong here. Can you guys observe? Right hand side says V2. Why am I writing V1? A small mistake there. V2, 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 and V2. This is my final answer for elastic collision. So I'll write the summary here. You'll use equation 1, conservation of momentum, conservation of kinetic energy. Okay. Using equation 1, you will find equation number 3. So this is how do you find equation number 1? Using conservation of momentum. Using equation number 2, which is formed due to conservation of kinetic energy, you find equation number 4. To find equation number 5, what do? We divide 4 by 3. We're gonna get equation number 5. Once you get equation number 5, substitute 5 in 1 to get what? To get 6. This is your seventh equation. Fine. Once you get the sixth equation, substitute 6 in 5 to get 7. That's it. So these are the steps. So how do you find one? Conservation of linear momentum. Okay, that m1 u1 plus m2 v2 gives you m1 u1 plus m1 v1 gives you m2 v1 plus m2 v2. Something whatever I wrote there. Okay, equation number 2 is used to conservation is used by finding conservation of kinetic energy. You'll get the answer. Using 1 you find 3, using 2 you find 4. How? Bring all the m1s to one side. That's the pattern. Okay, using 4 and 3, both of them together, divide, you'll get the equation number 5. Now odd number logic. Take the 5 and substitute in equation number 1 to get 6. Take the 6 and substitute in equation number 5 to get 7. Done with the answer. 5 marker. Okay, practice this. I'll send the PDF. Work per energy, the most important parts are done. Okay, I'll send you the PDF along with this, after this maybe. Once you practice this, practice the whole thing again. But you should be in a state to realize that, you know, both the collisions are not the same. Both are two different things. And supposed to keep that in mind. Cool. See you.